students, welcome back to physics session. Today our topic is relative motion in two dimension. Students, you can download the Spark Academy app. There are daily live classes, session doubt clarification, free material in the app, tips and tricks, with the tips and tricks explanation. Previous year's questions will be discussed. So admissions are open right now. In a week, physics session is on Tuesday and Friday. So students, join with us for regular updates, and if you are buying any course from the Spark Academy app, you can use the coupon code SAN10 and you will get the discount on that coupon code and you will be supporting me with that. Yeah, let us go to the topic. So today we are going to discuss the relative velocity in one dimension and relative velocity in two dimension. Mainly this concept we can discuss with the riverboat concept. Relative velocity in two dimension can be explained with the riverboat concept and rain man concept or rain umbrella concept. So let us discuss first. First our concept is relative velocity in one dimension. Is that visible? Yeah. Here our concept is relative velocity in one dimension. Velocity of one object with respect to second object. Velocity of the first object with respect to second object is equal to velocity of one, as these are vectors, we can write it as velocity of the object 2 minus difference in their velocities we need to take. So relative velocity is nothing but velocity of one object with respect to the other. Here we are taking two objects 1 and 2. Their difference gives the relative velocity. So here we are given with examples. Relative velocity of B with respect to A, we need to write velocity B with respect to A means VB minus VA. Sorry, here velocity of 1 with respect to 2 means we need to take difference V1 minus V2. In the case 1, if the objects are moving in the same direction, means A and B both are moving in the same direction with their speeds VA and VB, then velocity of object A with respect to B, we can write it as VA minus VB, and its magnitude we can find the magnitude also like VA minus VB by giving their speeds. Velocity of object with respect to another object means first object velocity minus second object. In case 2, if the objects are moving in opposite directions, we need to follow the sign convention. In positive x direction, the value need to take it as positive. Opposite direction, which is in negative x direction, that speed we need to take negative. So let us consider here velocity of object A with respect to B, velocity of A minus of minus VB, because VA is in positive x direction, VB is in negative x direction. So as per the concept, it is difference in their velocities. So we need to take VA minus VB, but VB is in negative direction, minus of minus, it will be VA plus VB. So in one dimension, about the relative velocity, they can ask the questions like this. Let us discuss with one example. There are two trains of lengths L1 and L2. So let us take initially the two trains of lengths L1 and L2 moving moving with their speeds in the same direction, and they can ask the question at what time they can cross each other. They cross each other. So here we can follow the relative velocity concept. The time taken to cross each other will be equal to, we need to take the relative distance by relative velocity. Relative distance means when they cross each other, the train L2, if it is crossing L1, it needs to travel this distance. So we have to take L1 plus L2 is the relative distance, and when they are in the same direction, relative velocity will be V1 minus V2. Same as like VA and VB are in same direction. VA minus VB is the velocity of object A with respect to B. In second case, if the trains are moving opposite to each other, this is the train 1, its length L1, and train 2, its length L2, and V1, V2. Now they are moving in opposite to each other. What is the time taken to cross each other? Here also we follow the relative velocity, that is relative distance by relative velocity. So relative motion we need to consider relative distance by relative velocity. Here relative distance, as it is a scalar, we need to add, because when they cross each other, it can travel that total distance. So L1 plus L2 by, when they are in opposite direction, this second case, we need to take V1 plus V2. So these type of questions can be asked about the relative motion in one dimension. So we have to consider in same direction relative velocity is difference in their velocities. In opposite direction, relative velocity is being equal to addition, adding their velocities. Our next concept is relative velocity in two dimension. So it can be explained with the riverboat concept. So to solve the riverboat concept here, we need to understand two concepts. Means mainly 2 points we need to keep in mind. The first point is speed of the boat relative to the water is equal to the speed of the boat in still water. Means in the question, if we are given with speed of the boat in still water, means that is speed of the boat with respect to river flow, or it can be given as speed of the boat relative to the water, or if they given speed of boat in still water, means we need to consider it is the relative velocity. And next point, relative velocity of a boat relative to the water will be equal to difference in the velocity of boat relative to ground and velocity of water relative to ground. Means by following relative velocity, velocity of boat with respect to river, velocity of boat with respect to river means Vb minus Vr. Here river flow means that water flow only. Means Vb is with respect to ground. If we are not giving any reference, that value is with respect to ground. So velocity of boat is nothing but velocity of boat with respect to ground. Similarly, velocity of water or river flow is with respect to the ground. So that is the velocity of boat with respect to river flow or relative velocity. So here I given like a formula is with water. Instead of river flow, we are considering here water. So velocity of boat with respect to water means velocity of boat with respect to ground minus velocity of water with respect to ground. Means any speed or velocity of that quantity is not given with the reference frame. We need to imagine that value is with respect to the ground. So these 2 points we need to keep in mind. Speed of boat in still water or speed of boat relative to water means it is the relative velocity with respect to the river. That is the meaning. And let us see the first case in the riverboat concept. if the boat is moving along the river, means we can, this is the motion in a relative motion in one dimension. So the boat is moving along the river. In that we have to understand the 2 points, upstream, downstream. Upstream means when the boat moves against the direction of flow of water, means that is opposite to direction of the stream. Means these are the banks of the river, and there is a boat in the river flow. This way there is a direction of the river flow. River flow we are considering this direction. If a boat is moving along with the river flow, that is called, opposite. Upstream is opposite, we need to consider. It is upstream. Opposite to direction of river flow, boat drives, that is upstream. Downstream means they can ask boat drives in the river opposite bank, or swimmer is swimming to the opposite bank. So boat person or a swimmer moves in the same direction as that of the stream. Stream means flow of the river only. So downstream means in this direction river flow, and the boat person is also driven that boat in the direction of the river flow, that is downstream. So here along the direction of the river flow, the boat is driven with the downstream. Opposite to the direction of the river flow, the boat is driven with upstream. So we need to keep in mind these points. So motion along the river means it is the example of relative motion in one dimension. We discussed the problems also. And our next concept is motion across the river. So in 3 ways they can ask the questions. When boat person crosses the river, means he is reaching the opposite bank. So the first case is general approach. So let us discuss with the diagram by giving the direction of the speeds. These two are the banks of the river, and the distance between the banks of the river is d, and velocity of the river flow is in this direction. And the boat person or a swimmer from point A from this bank, first bank 2, he is trying to reach the opposite bank, this point, but that boat person is making angle theta with the downstream. Downstream means along the river flow. So velocity of boat with respect to river flow is making angle theta with the velocity of river. Then he is reaching, instead of reaching opposite point, he reaches to this point, let us say D. So he travels some distance along the river flow. This distance along the river flow, the distance travelled by the boat is called drift. So due to this river flow, he drifted to some other place. So he is trying to reach opposite bank, but that boat person making angle theta with the river flow, he reaches to point B. So he travelled this much distance horizontally, which is called drift. So here this velocity vector resolve into its components as it is making angle theta with the horizontal. The horizontal side is VBR cos theta, and opposite to that angle, this side is VBR sin theta. Now, in this situation, in the general approach, when the boat person making angle theta with the river flow, they can ask the question, what is the time taken to cross the river? Time taken to cross the river means he needs to reach from point A to point B. So the component of velocity in that direction is VBR sin theta. So here component of relative velocity of boat is helping to reach the opposite bank. So we need to take time is equal to distance by speed. Here speed is VBR sin theta. So what is the time taken when boat person making angle theta with the river flow means we need to take to reach that distance, which component of velocity is there, that velocity we need to divide. So distance by speed. And next and if they are asking what is the relative velocity of the boat, means velocity of boat with respect to river. So this is the resultant of these two. So we need to take under root of what it is making angle theta. With that we can write VBR cos theta whole square plus VBR sin theta whole square. That is the relative velocity of the boat. And they can ask what is the distance along the river flow. What is the distance travelled by the boat person or a swimmer along the river flow means this distance. Along the river flow, this distance he travelled, that it is called drift. So that is drift. So we have to calculate the drift, which is the horizontal distance. So distance will be equal to velocity into time. So along this distance, with which speed he can travel means along that line there is a velocity of the river flow and VBR cos theta. So total velocity is VR plus river flow plus VBR cos theta into time. Time is, this is the time to reach the opposite bank. So we can write D by VBR sin theta. So this is the general approach. So they can ask what is the time taken to cross the river, or what is the distance travelled by the boat person along the river flow, or they can ask what is the relative velocity of the boat, means boat with respect to the river. And next case, he needs to reach the opposite bank in minimum time. So for that, let us observe this diagram once. So with this component of velocity from A to B, he can reach the opposite bank. So if this component is maximum, then time will be minimum. Means sin theta value should be maximum. This, for which angle it is maximum, we need to take theta is equal to 90. Then time will be minimum. So in a minimum time he can reach the opposite bank. So next we can write, just we are giving that situation with the vector notations. So in this direction there is a river flow. So when we put theta is equal to 90, here VBR sin theta becomes VBR and VBR cos theta will be 0. So in this direction there is only river flow. Now this resultant of these two will be the actual velocity of the boat, means velocity of boat with respect to the ground. Even in minimum time he travelled along the river flow, which is called drift. So to travel in a minimum time, we are giving the relative velocity of the boat, means he should reach opposite bank with river flow in a perpendicular direction. So now net velocity of the boat is being in this direction, which is the resultant of these two. So in this case, in a minimum time, what is the time taken to reach the opposite bank? So let us take the distance between the banks means needs to travel this much distance to reach the opposite bank. That is t is equal to distance by along the distance. Now this is the velocity which is VBR. So this is the minimum time taken to reach the opposite bank, and in this case while he is taking minimum time to reach the opposite bank, what is the velocity of the boat? Actual velocity of the boat they can ask. So here actual velocity of the boat means with respect to ground, it is the resultant of these two vectors. So we can write under root of VBR whole square plus these two are being perpendicular to each other, VR whole square. That is the actual velocity of the boat. And there is a drift in a minimum time, so that is called along the river flow. The distance travelled by the boat. The distance travelled by boat or swimmer. The questions can be asked, the boat person driven the boat or the swimmer swimming and reaching the opposite bank that way. So we need to find the drift in this case in a minimum time. That is x is equal to velocity into time taken. So along this distance, only component of velocity is river flow now. So the total velocity is river flow into time taken is, and that drift also while reaching the opposite bank only. So we can give like A, B and D. So when he is aiming to reach this point, but due to river flow there is a drift and he reaches this point. So we can write VR into time taken is distance by VBR. So this is another case. So in a minimum time to reach the opposite bank, we have to remember what is the time taken and what will be the actual velocity of the boat and what is the along the river flow distance travelled by the boat, which is called drift. So in these two cases, drift is not minimized due to river flow. He travelled along the river flow. So next case which we discuss here, shortest distance, which is the condition for minimizing the drift. Means no drift. So no drift means once let us observe the first two diagrams. When he is making angle theta with the downstream and with VBR cos theta is in this direction, relative velocity is from A to D. And next time, when he chooses the minimum time, VBR, this vector changes to this side and this will be the net boat velocity. Now we are choosing shortest path to reach the opposite bank. So if VBR is opposite to the river flow, if he is making angle theta opposite to river flow, means upstream, then net actual boat velocity will be perpendicular to the opposite bank. Then that is the shortest path he can travel. So you can observe in this diagram, this is VB. This is the actual boat velocity to reach opposite bank, which is the shortest path. For that, the boat person should make, he needs to travel making angle theta with upstream. Upstream means opposite to river flow. In this direction there is a river flow. And we can take the boat angle made by the direction of the boat with the shortest distance. This is the shortest distance is alpha. So we are going to find angle made by the direction of boat with upstream and direction of boat with the shortest distance. So in shortest distance, there is no drift. So he can reach opposite bank directly from point A to point B. And this is the relative velocity of the boat. So in this situation, the questions can be asked this way. What is the time taken to reach the opposite bank in a shortest distance? So time taken means he needs to travel this distance, that is the distance between the banks. So that distance by, along that distance there is an actual boat velocity. So we can take velocity of the boat, which is nothing but with respect to ground. This is the velocity of boat with respect to ground. So in a shortest distance, time taken is distance between the banks by velocity of the boat. And next, if they are asking what is the actual boat velocity, actually this case is exactly opposite to the first case in general approach. In general approach, we consider he is making angle theta with the downstream. To reach opposite bank directly, we are considering that boat person making angle theta with the upstream. So in this case, actual boat velocity will be, means from this we have to consider from this triangle, let it be A, B, C. So from triangle ABC, so we can write VB. Now VBR is the resultant, and in this direction there is a river flow, VR and VB. So it is being equal to under root of relative velocity of the boat whole square minus VR square. So by following vectors, so from this right angle triangle, just apply the Pythagoras theorem. We need, this is the side of this triangle. So VB is being equal to under root of relative velocity means velocity of boat with respect to river whole square minus VR square, like hypotenuse square minus side square. We are finding one of the side in the triangle. So this is the actual boat velocity. In the first case it is different. Actual boat velocity is not there. We just find the velocity of boat with respect to the river. So with the components we have measured, and the shortest distance is opposite to that case. So this is the actual boat velocity. And next, they can ask what is angle made by the direction of the boat angle made by direction of boat. First we find this one. Theta is the angle made by direction of boat with upstream. So we write with upstream. So from the same triangle ABC, and we are taking with upstream means here we are considering angle. So these two are alternate angles equal. So from triangle ABC, so let us take from triangle ABC, cos theta, which is the angle made by the direction of boat with upstream. Then cos theta from this triangle we have to write, that is adjacent by hypotenuse. So adjacent is VR by hypotenuse is VBR, and also angle made by the direction of the boat with shortest distance, means this is the shortest distance. Angle made by direction of boat with the shortest distance is alpha. So with the shortest distance we can write, so that is means reaching the opposite bank. For the river flow it is opposite. River flow is opposite to that angle. So we need to consider alpha, because here angle made is alpha. So sin alpha is also same as like VR by VBR. So if they are asking angle made by the direction of boat with upstream, consider cos theta from the same triangle, which is equal to VR by VBR, and angle made by the direction of boat with the shortest distance. Or this question they can ask, what is angle made by the direction of boat to minimize the drift? Any of the angle you can find like cos theta and sin alpha. Sin alpha is also being equal to VR by VBR. And lastly, if they are asking what is angle made by the direction of boat with the river flow, direction of boat with the river flow. So with the river flow means this is the direction of boat. He is aiming in this direction. So we need to find angle between direction of boat to river flow is in this direction. Actually, from starting case we consider river flow is in this direction, but he is aiming opposite to that, which is upstream. So with the direction of boat to river flow, this total angle we have to find, that is (90 plus alpha). So if they are asking angle made by the direction of boat with river flow means this total angle we have to consider. Here angle is 90 plus alpha. 90 plus alpha is with the river flow. With upstream means you can consider cos theta, VR by VR, and it is also angle made by the direction of boat with shortest distance. We need to find alpha, and the river flow is opposite to that, so we need to take sin alpha. And in this case, when it makes angle theta, river flow is adjacent to that, we consider cos theta. So here it is sin alpha. So need to be careful which angle they are asking. So in these three ways about the riverboat concept, we can expect the questions. It is the example of relative motion in 2 dimension. And our next concept is rain man problem, means rain umbrella concept. And one more example of relative motion in 2 dimension. So in this mainly we have to find the relative velocity, what will be the relative velocity of rain with respect to the man. So if rain is, this is the first case. In this case, if rain is falling vertically downwards with the speed VR, so that is the velocity of rain which is falling vertically downward, and this is the velocity of the man who is moving in eastward direction, in forward direction. So these are the directions of velocity of rain and velocity of the man. Now we have to find relative velocity of man with respect to, velocity of rain with respect to the man. So here, just by following the vectors, velocity of man is in east direction, and velocity of rain is vertically downward. So south direction, it is showing downward direction. But as per the relative velocity concept, velocity of rain with respect to man means we need to take VR minus Vm. So Vm negative vector we need to consider, so we have to draw minus Vm, and the resultant of these two will be velocity of rain with respect to the man. Now this is the resultant, which is the relative velocity of rain with respect to the man. So in this case, when rain is falling vertically downwards, minus Vm will be negative x direction. Now this resultant magnitude we can find by using the vectors law of addition, parallelogram law of vector addition. these two are being perpendicular to each other. So under root of Vm square plus Vr square, that is the magnitude of the relative velocity, which is the velocity of rain with respect to man, and direction of the resultant. So direction of the resultant, this resultant making alpha with the direction of velocity of rain. So tan alpha we have to consider, which is equal to velocity of the man by velocity of the rain. For example, if it is making angle alpha with the horizontal direction, this tan component changes. So angle made with vertical or angle made with the horizontal, we need to be careful with that. So if they are asking angle made with the horizontal, so we have to write tan theta is equal to, now this will be opposite sides will be equal, so it is Vm, so it will be equal to Vr by Vm. When resultant makes an angle theta with the horizontal, we need to find tan theta equal to Vr by Vm, and the direction of the resultant making alpha with the vertical is Vm by Vr. This is Vm by Vr. So this is the case when rain falling vertically downwards with some speed. And let us see the next case. If rain is already falling at some angle theta, and how do we can find the direction of the resultant and magnitude? So you can observe in this diagram, rain is falling vertically. It is making angle theta with the vertical direction, and the man is running in this direction towards east. And this is the vector notation with the directions. So velocity of man is along positive x direction, and rain is falling making angle theta with the vertical. So this is theta, like with the directions we can write minus Vm means we have to take this one, and this is the velocity of the rain, and now this will be the opposite side will be the relative velocity, which is the velocity of rain with respect to man. So we can write a magnitude of that relative velocity is from this triangle we can write under root of hypotenuse square minus side square, that is Vr square minus Vm square, and the direction of the resultant we can write here. We need to consider tan theta from the figure, either this or this one when it is making angle theta with the vertical. So tan theta will be equal to opposite by hypotenuse. Here hypotenuse is the velocity of the rain. So if rain is already falling at some angle theta, relative velocity is Vr square under root of Vr square minus Vm square, and the direction is, it is mod of Vm by Vr, means we need to find its magnitude. So this way we can find the direction. So these two are important in the rain man concept. Yeah, students, this is the information. You can download our app for great discounts on courses. So in the app there is a free handwritten notes, free study material, previous year's questions and mock tests. So link is given in the description, you can follow that. So classroom coaching and online coaching, short-term coaching are available, the timings are given. Yeah, don't forget to apply the coupon code. So if you are buying any course by my name, it is coupon code you need to enter Sandhya. So by using this you will get the discount on that. So there are daily and on-demand live sessions. So in our methodology is we start right from the basic concepts, shortcut methods, all model questions will be discussed, exercise questions, previous year's questions. Chapterwise tests will be conducted every weekend. Weekend tests, grand tests and test analysis will be given after the exam. and you can see here the schedule for the coaching. So let us see the problems related to the river boat. So here we are given with a boat which has a speed of 5 km per hour in still water. In still water means that is the velocity of boat with respect to the river. Is given as 5 km per hour. Crosses a river of width 1 km. River of width means that is a distance between the banks of the river, which is given as 1 km. Along the shortest possible path in 15 minutes. So it is the shortest distance case, third case of our concept. T is taken 15 minutes. Here velocity is given in kilometer per hour. So let us try to convert this into hour. So 15 by 60 in hours. Time we are taking in hours, and they are asking what is the velocity of the river. So here we have to take the third case in our concept, that is the shortest distance. The time taken to reach the opposite bank in a shortest path is distance between the banks by velocity of the boat. And actual velocity from the third case, actual velocity of the boat is VBR square minus VR square. These are the from third case we have these results. This question is the shortest possible path case. They are asking velocity of the river. So let us find first what is the velocity of the boat, where time is given, distance is given. So from this velocity of the boat is distance 1 km by time we have to take here. Time in hours we converted, that is 15 by 60. So which will be equal to 16 will go 4 times. So 4 km per hour. That is the velocity of the boat. Now we can use this result to find the velocity of the river. So from this we can write VR is equal to under root of VBR square minus VB square. So VBR is 5 kilometers, so 5 whole square minus VB we calculated it as 4, so 4 whole square. Even Krishna boards let us see this question. Velocity of a boat in still water means the relative velocity of boat with respect to river. 10 km per hour is given, and the velocity of river water is 5 km per hour. What is the time taken by the boat to travel a distance of 30 km downstream? So it is the case of motion in one dimension. So downstream means velocity of the river and velocity of boat, relative velocity of boat, both in the same direction along the river flow. Here time taken means we need to take the distance travelled by VBR plus VR, because these two are in the same direction. Sorry, minus. Downstream means the difference in the velocities. So here we can find the time taken by the boat. The distance travelled by 10 minus 5. Yeah. Distance is given as 30 kilometers. So substitute that 30 by 5. So 10 minus 5, it is equal to 5 here. So we can write it as 6 in hours. We substituted kilometer per hour, so time we get in hours. So this is the case relative motion in one dimension. So along the river flow there is a relative velocity. So time taken when they are in same direction, we consider difference in their velocities. And next case, what is the time taken by the boat if it travels the same distance upstream, means from the previous questions with the same values. So let us write that values again. VBR is 10 km, VR is 5 km per hour. VR, velocity of the river flow is 5 km per hour. And they are asking time taken and the distance travelled is given as 30 kilometers. The values are from the previous question, but we are finding with the upstream. Time taken by the boat if it travels same distance upstream, river flow and relative velocity opposite direction. Then the time taken will be distance by, now we need to take, these two are in opposite directions according to relative velocity concept. We need to take plus VBR plus VR. So it is 30 by 10 plus 5. So 30 by 15, 2 hours. So if we compare the times in downstream, if it is 10, which is 6 hours, it is taken 6 hours and it is less than time taken. So in a minimum time to travel that distance, the boat person should aim opposite to the river flow. That we have discussed in motion in 2-dimension riverboat concept. Yeah. So students, this is the required discussion today. And you can try, I have given few problems related to riverboat concept. A boat moves relative to water with velocity. So just list out the values and find the required quantity. And here I have given the questions related to rain man problems. Let us see, a man is walking on road with a velocity 3 km per hour. Suddenly rain starts falling. The velocity of rain is 10 km per hour, vertically downward direction. This is a rain man concept, case 1. So use that results, can solve this question and post your answer in the chat. And one more question, it is also about case 1 only. It is raining vertically downwards with a velocity of 3 km per hour. A man walks in the rain with a velocity of 4 km per hour. Raindrops will be falling on the man with a relative velocity of. So you have to find here velocity of rain with respect to man. So it is also case 1 only. So use that result about the case 1 and solve these questions. Thank you.